Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability Exercise 5.1. Already in the last videos up to question number 5, we have seen the solution, and now in this video, we are going to see the solution of question number 6. So let's have a look on what is the given question. Find all points of discontinuity of f where f is defined by. This is the function given and point they didn't mention, so it has to be understood that throughout the real line we have to we have to find out points of discontinuity. Okay, and here function is given. What is the function? 2x plus 3 also function, 2x minus 3 also function, but at different conditions. If x is less than or equal to 2, we have to use the first function. If x is greater than 2, we need to use the second function. Okay, so let's start with the solution. So given f of x, two different functions, right? One is 2x plus 3. This has to be used if x is less than or equal to 2. And second one is 2x minus 3 if x is greater than 2. Okay, so this is the given function. So now throughout the real line, are we going to use the single function? Obviously not. So now using the if condition, we can take it as a hint. We are going to break the real line at the point 2. So when we break the real line, when we break the real line, you can see two partitions, and at x equal to 2 also you have to keep it in the mind. So first in a case 1, we have to take the condition any x values which lies in between this. Okay, this is what x is less than 2. Okay, this way this area values, real values are less than 2. Okay, so case 1 we are going to check the continuity if x is less than 2. If x is less than 2 means we have infinite real values lies over here, right? So we are going to have a common name, like naming it as any variable. Suppose if we take it as the c, then f of c value, left hand limit of c. Okay, close values of the c in a left hand side as well as right hand side, right hand limit. All these three things we have to find out. If all these three things are coincide, then we can say that a given function is continuous if x is less than 2. Okay, and in case 2, case 2, if x is exactly 2, x is exactly 2 means f of 2 value, left hand limit of 2, okay, this side, and right hand side limit of 2. So these three things we have to find out. If all these three things are coincide, then we can say function is continuous at x equal to 2. In case if it is not continuous, and this point we can take it as a point of discontinuity. Even same way, if all these three values are not same, then we can say at this point is that less than 2, here function discontinuous we can say. Okay, all the real values which is less than 2, their function discontinuous, we can have a solution. And now this part is what this place is here real values are if x is greater than 2. Greater than 2, we are going to have a case 3. So that means greater than 2 also infinite real values we have. So again we can have a common name, and condition applies that c is the greater than 2. And same f of c value, left hand limit, right hand limit, we have to find out. Then we are going to check how the function is, all these three values are same or not, we are going to check. If all these three are same, then we can say function is continuous. If it is not same and this function discontinuous if x is greater than 2. Okay, so let's start with the case 1. Case 1, what is the criteria? If x is less than 2. Okay, if x is less than 2 means infinite real values are lies. So we are going to have a common name first. Let c be any real value. Okay, any real value at the same time c should be less than 2. Okay, now first f of c will find out. F of c is what? Less than 2, right? Out of these two given function, which function is suitable? First function. So f of x equal to 2x plus 3, and what is the input we are giving? C. So if f of x equal to 2x plus 3, then f of c will be 2c plus 3. Okay, now left hand limit. Left hand limit. And left hand side close values of c also obviously less than 2. Then limit x is approaching 2. from left hand side. Left hand side of 2 is what? Obviously less than 2. Less than 2 means again first function. Replacing f of x with the first function. First function is what? 2x plus 3. And left hand side close values of the c approximately c. So we can directly replace. Okay, we can directly replace. Oh, sorry, this is c. We are testing continuity for C, no? So this is C. Now left hand side closed values of C also is approximately C. Now directly replacing X as a C. Then 2C plus 3. Okay. And next one, right hand side limit. Right hand side closed values of C, limit X is approaching to C from right side. Right hand side closed values of C is also less than 2 only. If it is less than 2, again first function only we have to replace in place of f of x. And closed values of the c in the right hand side also, it's approximately c. Now replacing x as a c, that is 2c plus 3. And now if you notice, left hand limit, right hand limit, and f of c values are same. So here f of c value, left hand limit, right hand limit, all these three things are same. So f of x is continuous. What is the condition that we have taken? Less than 2. F of x is continuous if x is less than 2. Okay, so here function is continuous. Okay, and one more clarification I will give here. So here c we have taken, right? So suppose c is what? Less than 2. So less than 2 means for sample purpose I will just take it as a 0. 0 is also less than 2, right? Now close values of 0 in the left hand side also, obviously what? Less than 2. And right hand side close values of 0, 0, right hand side values which lies this those values we should not take. Only the close values, that is 0.001. Even when we round it, approximately 0 has to come. Such type of close values only we have to consider. Even the close values of the right hand side limit also, I mean for this 0 also, it is less than 2 only. Okay, so with the c, that's the reason even for the left hand limit also we applied 2x plus 3. If for right hand side limit also we applied same 2x plus 3. Okay, for 0, left hand side close values and right hand side close values anyway less than 2. Okay, so we should not consider the values which lies in the right side. Right side obviously we have positive numbers like 1000, 200, 250, 5. These values are lies. These values are obviously greater than 2, but those values we should not consider. So when we talk about the values which very close values only we have to consider, okay, while applying the limit. So now we can move on to case 2. Okay, case 2 is what? If x is exactly 2. Case 2 is if x is exactly 2. Okay, then f of 2. Now, two given functions, right? So, if x is exactly 2, we have to use the first function, 2x plus 3. F of x is 2x plus 3. Then, f of 2 will be 2x. In place of x, we have to replace 2 plus 3. 2 2s are 4, 4 plus 3. 4 plus 3 is 7. Now, left hand limit. Now left hand side close values of 2 is what? Less than 2. That means first function we have to replace. Now limit x is approaching 2 from the left hand side f of x. First function is what? 2x plus 3. And close values of the 2 obviously approximately 2. Now replacing x as a 2. So when we replace we are getting the left hand limit as a 7. Okay, so now right hand side limit. Right hand side limit x is approaching 2 from right hand side f of x, and right hand side close values of 2 is greater than 2, like 2.001. Whatever values lies in the right side of the 2, no, I mean not all the values, which is very close values only I am talking. So those close values are obviously greater than 2. If it is greater than 2, from given we need to choose the second function. Okay, so 2x minus 3. Now f of x has to be replaced with the second function, that is 2x minus 3. Now close values of the 2, that is very close, 2.001, approximately 2. So while applying the limit we are going to consider x as a 2. So we are going to substitute the same which value it's approaching towards 2. So that means in place of x we have to replace the same value. So 4 minus 3, that is 1. Now if you notice, left hand limit, right hand limit is not coincide, right? Left hand limit, right hand side limits are not same. So f of x discontinuous at where? At x equal to 2. F of x is discontinuous at x equal to 2. So only at this place, as of now, function discontinuous. Now we'll test the continuity for this if x is greater than 2. That is case 3. Case 3, if x is greater than 2. Okay, greater than 2 means again infinite real values are lies. So we are going to have a common name. Let C be any real value at the same time C should be greater than 2. Okay, so that means C lies somewhere here, right? So now f of C we have to find out. So f of C, what is the condition for the C should be greater than 2. If it is greater than 2, which function is suitable? 2x minus 3. So here what is the input? C. So 2c minus 3. Now close values of the C in the left hand side as well as in right hand side is also greater than 2. Okay, is also greater than 2. So for both, while finding the left hand limit, right hand side limit, we are going to use the again second function only. So left hand side limit, limit x is approaching to the C from left hand side f of x. So what is the f of x? Close values of the C in the left hand side also greater than 2. So replacing f of x with the second function, that is 2x minus 3. Now applying the limit 2c minus 3. Now right hand side limit x is approaching to C from right hand side f of x. Even right hand side close values of the C is greater than 2. Now replacing function with the second function, that is 2x minus 3. Applying the limit 2c minus 3. Now if you notice here, f of C value, left hand limit, right hand limit, all the three results are same. When all the three results same, what is the conclusion? F of x is continuous where x is greater than 2. F of x is continuous if x is greater than 2. Okay, now from above all three condition, when we notice we broke the real line this way, right? So in case 1, what is the conclusion? F of x is continuous if x is less than 2. So for all the values, so 0, 1, any real values, okay, 0.5, 0.6, even for negative values also lies this side. So for any real value which is less than 2, function is continuous only, always continuous. Okay, and at x is exactly 2, what is the solution that we got? Discontinuous. So function is discontinuous at x equal to 2. Again, when we tested for x is greater than 2, function is continuous. So what is the overall conclusion? What is the question is about? The question they're asking here, find all points of discontinuity of f. So overall review is what? So function discontinuous only at x equal to 2. Okay, none of the real values the function is not, function is continuous. Okay, throughout the real line function is continuous, only at x equal to 2 function is discontinuous. So the same thing we are going to write it as a conclusion. Here from above cases, function when given f of x, okay, function discontinuous only at x equal to 2. Okay, other than 2, for all the real values function is continuous only. So that's all the solution for the 6th sum. Okay, and now in 7th sum we can continue in the next video, and thanks for watching, and please do subscribe. Thank you.